Okay, thank you very much for joining today's session. So today we are starting a new unit, which is we're going to look into cloud computing and DevOps. So in this unit, we will have four learning outcomes, which will be 4 tutorials. And then we will conclude with assignment discussion, where we will now um, look into the tasks that are required for us to complete our assignment. So what is the unit aim? The aim of this unit is to equip students with the knowledge and skills required to work with cloud computing and DevOps. This includes learning about various computing models, such as infrastructures as a service, platform as a service, and software as a service. And then complete knowledge of different service hosted in cloud, continuous integration, CI, and continuous delivery, CD. Automation with various cutting-edge technologies with practical experience. Upon completion of this course, students should have solid understanding of the role, benefit, and challenges of cloud computing and DevOps, able to apply this principle and practice in a real-world scenario. So we have now looked into what is the aim of this unit, and we'll now dive into our tutorial. So I have a presentation. So learning outcome 1, we now have to be able to understand and implement continuous integration and continuous delivery process and techniques. So what do we know about cloud computing? Before we dive into the tutorial, just want to know a bit of what do you know about cloud computing. So give me what is your overview of this technology?
Cloud computing is essentially the management and control of all the things such as servers and backup platforms.
Yeah.
Cloud computing. It's like you're being able to create them from scratch via these it's like Netflix, how Netflix is a cloud platform, because if you're streaming with the use of Amazon's AWS, things like that.
Exactly. Yeah, you're getting it right. So let's start from the very beginning. So let me give you a bit of more introduction. So I don't know if you're familiar with the word big data. So big data is simply when we look into back in the days, maybe early 2000, there wasn't much software application as we see nowadays. So the amount of data that was generated back then was very limited compared to the amount of data that we see nowadays. So back in the days, maybe they used to just send emails or access few amount of data. But with the introduction of social media and all these applications like Airbnb, Booking.com, or whatever, we have now generated a very, very large amount of data. That's why we now have big data, and the way for us to not having our server to crash, we now need to store all this data into the cloud. So cloud computing is essentially remote servers around the globe, which we can now access them, which we can basically access them remotely. So for instance, if you look into software like Instagram, or for instance, if Joshua comes up with a new idea of a new social media, and he now launches it on the market, you will initially start with maybe 1 or 2 users, which your actual server can handle. You now get to 10 users, your server is still able to handle. But if your application is really good and it grows exponentially and you find yourself having, I don't know, 100,000 or maybe 500,000 user subscribers, your server will now start to crash because your server cannot handle such amount of data. That is the reason why we now need cloud computing. We now need this technology. That's where, as you said, we have Amazon Web Server. This is when these companies will now come into place, and they'll now provide you their own service where they'll now ensure that there is data integrity, there's no any type of data breach, there will be a lot of security, and they're providing you a service where you now only have to handle, you don't have to handle all these other components. You're just looking into the data. So you're just looking into maintaining the code and maintaining your software.
Okay.
As we mentioned before from the unit specification, we have 3 types of cloud models, which are infrastructure as a server, platform as a server, and software as a server. So exactly how you mentioned Netflix earlier on, Netflix is a software as a server. So what does Netflix do? Netflix provides you a software which can be accessed remotely anywhere around the world by you just simply logging in. And this software is now hosted entirely on what's the name again? Amazon Web Server. So Netflix relies heavily on Amazon Web Server because all the backend, all the data is handled entirely by Amazon Web Service. Then we have other type of models, platform as a server, where it just allows you to, with this platform, so Joshua has now created a new application. He can now use this platform to host the new software. And then we have infrastructure as a service, which is pretty much similar to platform, but is a whole infrastructure. So, for example, Google can be classified as a infrastructure as a service where
you like Google Drive.
Sorry?
Like Google Drive.
Yes, that's the whole infrastructure.
That's an infrastructure?
Yeah.
Because it's already part of a bigger thing, isn't it? Like Google Drive. You have OneDrive. There's all these simple storage clouds.
Yeah.
Cloud storage.
Yeah, so basically that is classified as an infrastructure where it allows you to build and work with different type of applications and softwares, and all of them will be hosted into that infrastructure.
I see.
Yeah, so we've now given overview of cloud computing. So for example, we have different type of brand. So we have Amazon Web Server, which was introduced back in 2006, I believe. Then we have Microsoft Azure. Then we have Google, the one for Google. I'm missing out the name at the moment. We have IBM Cloud and so on. So all these companies, they now, what do you call it? They're investing heavily on cloud computing because this is the future. This is where the technology is heading. That's where technologies are at the moment. So we know, yeah.
Like all these things like YouTube, learning platforms, things like that, that like obviously you can't store all of the documents and videos for like entire lectures like that, but so big. So anything that feels like it will be too much for the website, they
Yeah,
just use cloud computing, don't they?
yeah,
Like
basically,
some kind of extra storage or something for the back end, so that way it's not
actually,
stored on the website database, but rather stored on a kind of cloud.
remote, yeah, on the cloud.
I see.
Yeah,
So
so
that means that Netflix's website is just the front for all of the database information to be on the cloud. Am I right?
yeah, everything that you see on Netflix when it comes to the backend or storage and stuff like that, everything is hosted on AWS. Yeah,
Ah,
yeah,
okay.
because obviously, Netflix is a huge company and they have I don't know, billions of subscribers, and they cannot rely on the back-end engineers to maintain this or outsource third-party companies. They must rely on cloud technology. So they have no options than have everything hosted on AWS. Yeah,
Okay.
yeah. So we've talked about that one. Yeah. So I'll give an introduction. Let's look into what is continuous integration and continuous delivery. So whenever you work as a coder, as a developer, you will always come into stages where you've now created your program, but we can't deploy. So um, before deploying, they have to go through testing and a whole life cycle process where they'll test, review the code, deploy, and then they'll maintain. So with the continuous integration and continuous delivery, these are practices that aim to improve the software development process by enhancing, enhancing the speed and reliability of the software development. So with continuous integration, what happens is a development practice where developers will now integrate code into a shared repository. So by shared repository, we're now talking about um, um, a virtual control system, and this is done through Git. So when developers are working on a project, and if someone makes a changes, and there's another coder who is hand on the code to improve it, they'll now use a virtual control system where um, someone can put like a lock on the code, no one can touch it, or they can leave it there where other developers can now work on it to improve this software. So this is an example of continuous integration where developers continuously come and improve the quality of the code. And then we have continuous delivery, which is an extension of continuous integration. And this will now focus on ensuring that the software can be reliably released at any time. So with this continuous delivery, will now involve automating the releases process so that new code can be deployed to production simply with a push of a button.
I'm trying to understand the CI and TD again. So continuous integration is essentially just trying to test it every single day. Am I right?
Integrating, yes. So we test, yeah, we improve the code, we improve the quality of the code.
Of the cloud. Of
No,
you're essentially testing every stages of the cloud, while delivery is the final push before you press the deployment button.
yes.
I see. You know, it just confused me, the wording, continuous delivery. I'm thinking, okay.
No, yeah, exactly.
All right then.
So when it comes to looking at continuous integration and continuous delivery, as I mentioned before, before developers will now deploy a code, this will now has to be reviewed and improved with the virtual control system, and this really aligns with agile methodology. I'm not sure if you're familiar to agile. Are you?
Yes, yeah, I did the course of Agile.
Yeah, exactly. So you know what a
Prototype,
system, you know what a system development life cycle is basically.
yeah,
So
it's just trying to put into, like any other project, it's just trying to plan out what you need to do for each stage.
exactly, that's why
You
we see
use the
this.
waterfall effect, something like that.
Yeah, exactly. That's why some
The
system.
scrum of which one is who's meant to do what, things like that.
Yeah, that's where we come. Continuous integration and continuous delivery comes into place. So because we are not deploying straight away, that's why we need continuous improvement. That's why we need these two concepts to come into place. And things like DevOps, you know what our DevOps are?
Pardon?
Do you know what DevOps engineers are? Do you know what they do?
DevOps. I do not know what they do.
So a DevOps is development operation, for example, engineer. So they just sitting in between the development team and the IT operation team. So what they do, they ensures that there is like smooth communication and collaboration between coders, programmers, and the IT team, and those who have to like deal with the customers, or maybe, for example, um, you now build a software like Zoom, or I don't know, any um, software as a service. You have your own coders who work on the code, and then they have the IT support team. So DevOps sits in between these two categories, these two teams, and they just ensure that everything goes smooth. So the developers with um, ability to understand what the IT team needs for them to work efficiently. So we mentioned virtual control system, where with tools like Git, I don't know if you're familiar to Git, this will now allows developers to work simultaneously on the project. Then, because as we said, this is part of the system development lifecycle, we now need to, before deploying, we need to test the code. That's why we have software testers, and testers have different type of tools to test. So for example, we have tools like Jenkins and many other ones. So there are different type of testers. There's automation tester, unit tester, integration tester. So when it comes to testing, there are various type of testing that has to be done on the code before being deployed. And as I mentioned, there are various type of tools depending on what testing we're doing. So, for example, when it comes to automation testing, we will now use Gency. When we have deployment automation, we will now use tools like Ansible, Shift, Puppet, and when it has to come to monitoring the performance and the runtime of our software, we will now use software like Ledgers, Prometheus, ALK, which they all provide insight into our system performance and the application health. So here we have steps that shows us how we will now implement our continuous integration. So obviously we need to set up our version control repository, where we now create our folder.
That's my
Sorry.
phone. Let me just send a message.
Did you say something?
Apologies, it's just my phone. I'm just turning it on.
So, I don't understand. What did you say?
Sorry, my phone was going off. I had to tell it to turn off.
Okay, no problem. Yeah, as we said, basically when it comes to implementing CI, we simply following the process of software testers, how the software tester will now come into testing the code before testing our developer code before being deployed into the cloud or into the server. So we now need to set up our environment. When creating our folders with our code, and we now use a version control repository with the Git. Then we now looking to integrate automation testing, where we're going to ensure that every commit triggers an automated test suite. Then we have automated build, where we're going to configure a CI server to automate build process after every commit. And then we'll now have regular integration, where we will now encourage developers to commit code frequently. When it comes to continuous development, we now automate deployment pipelines. So what do we mean? We're going to set up scripts and tools to automate deployment to different environments. Configuration management. So we now use tools to manage environment configuration and ensure consistency. Then we'll have automated acceptance testing, which is going to implement automated tests that run after deployment to verify functionality in the target environment. And lastly, we'll now have continuous monitoring and feedback, where we now continue gathering data for us to improve our user experience and user maintenance, UI and UX, and so on. So let's look into what are the benefits of having a continuous integration and continuous development. So we now have faster time to market. So we have now scalability, where we can now accelerate the development process, allowing our team to deliver features more quickly. We have improved our quality. So by having this automated testing and continuous feedback loops, this will now favor our team, and it will now allow us to have high code quality. We're also going to reduce the risk, where we will now have smaller incremental update, which are going to reduce the risk associated with big releases, big software releases. And what could be the challenges? for our continuous integration and continuous delivery. This can now relate to cultural shift, where by implementing this method, we now require a shift in team culture and process, which can be challenging. So this will now look into changes and implementing changes within our IT team, where there are new procedures and new streamlines, and we now have to look at how this can improve our team, or if it's going to be if it's going to affect the productivity of our team. Then also we have challenges when it comes to the tools integration. So when it comes to integrating new tools, it's not always a smooth process, where the users, the IT professionals, has to come to understand the new features of the tools and how they have to use them and maximize all the features of them. Maintenance and automation scripts. So keeping the automation scripts up to date requires ongoing effort. So this can be quite challenging, where the team now has to understand and have the ability to keep this ongoing. So to conclude, the implementation of CI and CD process and techniques fundamentally transform software development and delivery. So these two concepts are really, really important when it comes to working with system development lifecycle, and our DevOps team heavily rely on this concept for them to constantly improve quality of code and ensure that each team within the company is able to work with them. So now we're going to look at ATHE 1.1, where we're going to define and integrate version control process with continuous integration, continuous delivery system like Jenkins. So we have already introduced what version control is. So in the practice of managing challenges to code documentation and other collection of integration, this will now enable multiple developers to work on projects simultaneously, keeping track of every alteration of our code. So when it comes to these two concepts, they rely heavily on version control system to streamline the development of and deployment process. So as I mentioned, we use open source softwares like Git, which are essential for maintaining the code and the data integrity.
Yeah, so it's easy to share, with other people about how it works.
Yes, basically, yeah.
This is that platform where you can share codes, isn't it?
Yeah, it's basically so I don't know if
Like
you know
GitHub.
You know what GitHub is?
Well, I've heard of it. I don't exactly know exactly what they do.
All right. So say for instance, Joshua, you're looking to get your first job as a junior software developer, and then you're now getting in contact with the company which is hiring junior developers. They want to know how you code, so they want to look into your past project. So GitHub is simply a platform where companies goes into it and they look up look into your project. So for instance, if you ever build a project now with JavaScript, or you build something with C, C Sharp, C++, and you want people to see your work, you now
And
upload
you can,
all this.
yeah, and you
You,
can also make it private or public.
yeah, exactly. Yeah. So you
Oh, so
can
it's like a space where you can save all your
your
codes,
work.
your
Yeah, yeah.
old
So that
projects. Like maybe I made a website and that's where it is. So maybe I made a program and I can place it there, but I can
yes,
also keep it, secure.
yeah, it's a hub. So it's called
Oh,
GitHub.
okay.
Yeah, where you
Uh-huh.
just upload all your files in there,
Useful.
and then recruiter or whoever in the company is hiring can just look into your code, and they can understand how you code, and they see if
If
you're
the
good enough. Yeah,
code is up to snuff.
yeah. That's basically for you to showcase GitHub,
Showcase
to showcase, yeah, your skills.
your skills to other employers.
Yes. While Git, it's a version control system. So
Yes.
Git will now be used within the team for them to access the code, the project, and they can now maintain the code and ensure that there is data integrity
Okay.
within the project.
There was
So
one like Jenkins or something. You wrote down like Jenkins.
yeah,
What's that? Is that a platform?
yeah, it's simply like a tool that allows you to do software testing.
Ah, okay.
Yeah. So I'm pretty sure you're familiar with the system development life cycle, where we have planning phase, design,
Design,
implementation.
implementation, testing, deployment, then maintenance. You have to keep the flow going. Yes.
Yes. So while working with version control system, you now have the whole team able to access the code, and they have to use um, continuous integration and continuous deployment, sorry, to ensure that there is data integrity within their system development lifecycle. Yeah, so we've mentioned Genskin, which is a popular open source tool. So I think you know what the open source tool is. For example, Visual Studio Code is an open source where people can now download and create code in it. Then you will now have other type of software which they're not open source. So they'll come now with a plan. So for example, if you know there's a company called JetBrains where they, they release loads of applications, which some of them are open source and other ones they come with a plan because they're used by companies like big, large corporations to uh, create softwares. So Genskin is open source, as we said. People can now access it for the simple purpose of testing and looking into uh, deploying software. So what are the integration steps? We're now going to set up our version control system. So we now have our repository creation, where we now going to create our folders and we now upload them into GitHub.
Mm.
Then here we have an example where we now install Genskin. We just need to download it from the official website and set up our environment. Then we now have to install Git plugins. So I hope you're familiar with plugins and what they used for. Then we'll now add credential. So we'll now, for instance, set up our own account and we're now good to go to create our new project. So we have mentioned automated testing and deployment automation. Okay, now we are looking into demonstrate Git branching and review the code. So what is Git branching? This is simply a core features that allows the developers to create independent lines of development within a repository. This will now facilitate parallel development, experimentation, and seamless integration of new features without disrupting the main code base. So we're simply working on new features, which this code does not affect the other lines of our code, and they can easily be tested. What is a pull request? By having a pull request, developers will now push their branches to a remote repository to create a pull request to merge changes into the main branch. A pull requests are reviewed by other team members to ensure that the code quality and adherence to standards. So we also have to review our pull request. How do we do this? By checking the code quality, readability, and maintainability. We also, another way to review this is to ensure that the code standards and best practice are followed. Also, we're now going to verify that the code is well documented and includes necessary comments. So it is very important when working on a project, which you're not the only one that's accessing it, but all the developers are working on it. It's very important that we add comment, we explain what these methods or functions are used for. It'll be easier for another developer to understand what is happening. So we now look for potential security vulnerabilities and performance issues. So when it comes to analyzing different source code management techniques and secure coding practice, we now look into centralized version control system and what they do. So for example, we have Subversion, SVN, Perforce. So what are the features of this control system? We now have a single central repository and they are easier to set up. What could be the challenges with them? They are limited offline work capabilities, higher risk of repository corruption, so they're easily hackable. Disrupted version control system, example, Git, as we mentioned so far. What are the features? This, for them, each developer has the full copy of the repository, excellent branching and merging capabilities, and a better offline support. So the benefit of Git is that we now have enhanced collaboration, fast operation, and a robust branching and merging. When it comes to secure the code in practice,
So between something like an SVN and Git is that Git is like a third-party version, whereas SVN is more, if it's inside it's more
centralized. Yeah.
Centralized. I'm trying to understand what you mean by centralized. Like, is it like more only for that company or something?
Yeah, it is for that company, but not many users can access it. While Git is
It's for bigger projects, isn't it?
multiple developers. Yeah,
It's more like you can't do it. GitHub is like something more personal, whereas the SVN is something more like a more global project.
HVN, you said SVN.
SVN, yeah, it's like
Oh
something like bigger, like a bigger global project. Like maybe you're working with someone in Australia.
no, it's just a concept. So SVN is more centralized version control. So you're not allowing as much people to access your code, while
Oh,
Git is distributed.
it's
So
just
it allows multiple developers, maybe around the globe, as you say, maybe someone in Australia to access the code. So it's
okay.
more like a concept of centralized and decentralized.
All right, I think I understand.
Yeah. Um, secure code in practice. So we have different methods to keep our codes secured. So we have data encryption, for example. So by having data encryption, our sensitive data are now protected, and it is not easy to decrypt um, our data. So we now ensuring that we have data integrity and we are far away from any sort of vulnerability. We have input validation where we're going to validate the input to prevent uh, injection attacks. So we know different type of cyber attacks that can occur, such as SQL injection, cross-site scripting, and so on. Then we have authentication and access control, where we're going to implement strong authentication mechanism. So we ensuring, say, for example, 2FA. I don't know if you're familiar to 2FA, could be a good authentication and access control, or even one-time passcode. So these are all um, techniques or additional steps, layers for us to keep um, se- um, the security of our to keep the access limited for or to only designated users. So
Like a
people who have
two-factor, like a two-factor authentication.
yeah, so it's a good authentication factor. So it allows simply maybe one user or whoever has um, the password or whatever to access this data. Okay, so now we're going to review in pull request for code reviews. So we're going to understanding and scanning source code for vulnerabilities. So what does this mean? We're going to ensure that the code is secure and free from vulnerabilities. Use automated tools and manually inspection methods. So what do? We have steps for reviewing a pull request. So we need to automate our code scanning. So we need to ensure that maybe every quarterly or monthly or even weekly, um, there are these um, automated code scan where we're going to integrate static code analysis tools, which allows us to improve um, the pipeline of our code. So depending on when do we want to review the code, we now choose and use these tools to review the code. Also, we can use manual code reviews, which has its own advantage and disadvantage. So with a manual code review, we're going to check for adherence to coding standards and best practice. We're going to ensure that all new code is well documented and understandable. And we're also going to look for potential security vulnerabilities. So by having a manual review where our software tester goes in and check, we're now going to look for insecure handling of user input, improper authentication and authorization mechanism, and a poor error handling that could expose sensitive information. Also, it is important to review the test coverage. So what do we mean by this? We're going to verify that the new code includes appropriate unit and integration testing. So we also have security best practice and feedback and iteration. So these are part of our UI and UX process, where we're going to gather useful data and we now give feedback to ensure and see what we can improve with our application. Now we have to design and implement our continuous integration, continuous deploy automated stages.
When I anticipated in terms of this cloud computing, and this is the stage where where is continuous integration planning everything, isn't it? Like this 1.2 was just planning everything, trying to sort things out.
Yeah, so all these steps are useful when it comes
using GitHub, using Jenkins, which I've never heard of before until today.
Yeah, they're more related to software testing because these are all part of our system development. Yeah, so basically these are all concepts that are part of our system development life cycle before hosting into Amazon Web Server.
Oh.
Yeah, so I don't know if we could look into all of them or we can simply move on because these AC, most of them, they're just covering what our software tester is required to do. And moving on our 1.4, we're now looking to deploy them into our cloud service. So previously we looked into our system development lifecycle, and now we have got to the point where we are ready to deploy into our platform as a service. So we're now looking into deploying free code into cloud service. And our cloud services, as we mentioned, the popular one is Amazon Web Server, where we have Amazon EC2, which is a scalable virtual server. Then we have AWS Elastic Beanstalk, which is easy to use service to deploy and scaling web application. And then we have Amazon AWS Lambda, which is a serverless compute service.
Different types of services for Amazon Web Services.
Yeah. So there are different types depending on what application you're building and what your application needs. So this looks into the needs of your application. Then we have Microsoft Azure,
Okay.
which is a cloud computing technology built by Microsoft,
Absolutely.
which has its own different type of um, hosting platforms. So you have Azure Virtual Machine, Azure App Service, and Azure Functions. Then we have Google Cloud Platform, which comes with Google Compute Engine, Google App Engine, and Google Cloud Functions. Then we have, as I mentioned earlier, we have all the type of, these are the most popular ones, but then we have IBM Cloud, we have Terramark, and many other less known companies. So now we mentioned Jenkins, and here we have an explanation of the steps that we have to follow to deploy our application with Jenkins into our cloud computing. So obviously we need to configure Jenkins to the cloud deployment platform. We now have to define our deployment stages in Jenkins, which we're going to add stages to deploy the application to the cloud service. We'll obviously have to create our file, which will go with the GitLab extension. Then we're going to configure our GitLab for cloud deployment. We now have a use case of provisioning infrastructure with CI pipelines, where we have infrastructure as a code, ISC, which will now use tools like Terraform, AWS CloudFormation to define and manage infrastructure as a code. Then we have automated environment setup, where we're going to automatically set up our deployment stage in our production environment. Also, we have dynamic scaling, which is going to automatically scale our infrastructure based on application needs. Then we have disaster recovery, that is going to automate the creation of a backup environment. And then we have security and compliance, where we're going to implement security best practices as part of our CI pipelines. We have a use case example here of a provision with Terraform. So as I mentioned, Terraform is a less known company which provide cloud computing service like AWS. Here we have a simple code where it shows us how this deployment will now be done with Jenkins file. And
I'm sorry, I missed the code there. Where was it?
sorry, yeah.
Oh, pipeline. Telephone. You see. Access code, secret access key. Okay, and that's the GitHub URL.
Yeah, basically that's the URL. And finally, so this is our last learning outcome for the day, where we're going to be able to automate the manual jobs and process. So by having an automated manual job and processing CI and CD pipeline, we have to, step one, have an evaluation of risk in automation. So by having automated manual job and processing CI pipeline, those will now bring numerous benefits, such as increased efficiency, will now reduce the number of errors and we're now going to fast our delivery. We're now looking into security vulnerabilities, where automation can introduce security vulnerabilities if not properly managed. So we have to go with our risk assessment and check into the type of vulnerabilities that could occur and how our data integrity could be put at risk. We have lack of human oversight. Obviously, as an end user, there is human error, where human can now perform errors which has to be catch immediately. You have to catch them immediately or before it leads to bigger issues. And also we have misconfigurations, where automated deployment script can propagate misconfiguration across multiple environments. Then we have dependency risk, where automated systems rely heavily on third-party dependencies, which might introduce vulnerabilities. And also we have data leakage, where improper handling of sensitive data within automated scripts can lead to data leakage. Now we have integration security tools within pipelines. So there are different steps to follow when it comes to integrate security tools. So we have static application security testing. Then we have dynamic application security testing and software composition analysis. And lastly, we have secrets management, which are tools to securely managing secrets and credentials used in continuous integration pipelines. And then lastly, we'll have continuous monitoring and logging, which are going to implement continuous monitoring and logging to detect and respond to security incidents. Lastly, we have recommendation for us to secure our continuous integration and continuous deploy automation, where we have to regularly update security tools, enforce code reviews practice, where we're going to manually check the code, implement role-based access control, audit and logging. So we look into audit trails and faster logins from other users. And then we have continuous learning and training to keep up to date with new releases and how technology is moving forward. So this was everything for today's session. Is there any question?
Yes. Everything you just said, all this new glossary of words and things like that, will we find all of these on the Amazon, on these AWSs and Google and Microsoft clouds to be utilized on them? Because
Not really. These are basically for you to. It's not that you see them on a day-to-day basis, but these are fundamentals. So these are something for you to grasp and to have a basic knowledge of how to work as a cloud computing engineer. So you wouldn't see this on a day-to-day duties, but it is best for you to have the fundamentals.
Right.
So your employer wouldn't have to train you on this stuff because you're coming prepared. You already know You're not an expert, but you have the fundamentals. You have basic understanding of this concept, which will be easier for you to now work with your employer because he doesn't have to train you on all these concepts. If that makes sense.
Okay, is this unit distinction or does pass and fail?
I believe this is a OTHM. Let me just check. Pass or fail.
Okay, pass or fail.
Can you see here?
I see it.
Unit grading structure is pass or fail. Yeah.
Yes. We will be looking at how to create like a cloud on the AWS.
So just by having a look at the assignment, you've been given with two sections. So obviously your first section will for you to create your Word document where you go through explaining different, all the methods. Section B, provision cloud service.
Will be the practical.
Yeah. You ask you install a CI tool and configure version control system. So you'll be asked to create Git, your account with Git, and create your microservices. Does that make sense?
It makes sense. Now, that's the other thing I wanted to get to. With AWS, you particularly said that they'll allow you to create all types of platforms, whether it's software as a service, platform as a service, and infrastructure as a service. But which one does what for Amazon Web Service? Because they have so many names, I'm wondering which one is used for.
Software as a service, you make the software, you upload it, and the only thing that you look into is the data. While when it comes to the platform, you're not just looking at data, but you're looking at the application as well. So you're looking into the code and other stuff like that. When infrastructure, you're looking into data, application, operating system. So you're looking into more things. So the infrastructure is, for example, operating system, you might be using a Mac or Windows or a Linux machine. So it's more, or you look into the network. Like you have more stuff to look into with infrastructure. Platform is you're just looking into data and application. And software, you're just looking into the data. So software, for example, Amazon will now just look into, no, sorry, not Amazon, Netflix will now look into the users, the data, the amount of people that are logging in. While if you're looking at platform, your platform as a service, you're more looking at data and application. So you're now still maintaining the code and stuff like that. For infrastructure, you're not just looking at data application, but you're even looking at more things like operating system, networking, and stuff like that. Does that make sense?
I think so.
Yeah, so there's a big difference between the three of them. So I'll say software as a service requires less stuff to do because you're just looking at the data, at your data warehouse.
Okay. Yeah, I think I understand.
Right?
Yeah, I think I understand quite a bit more now of what you're saying.
Yeah. So I don't know if you have any other question.
No, I don't.
No other questions. So if there is no other question, I will see you tomorrow.
No, thank you.
Thank you, Joshua, for joining on. See you tomorrow.
Mm, mm.
Yeah, bye.